It was going guys, Xiangqi here. So the last video we ended up figuring out whether the square is on board or off board, and since then I've implemented quite a plenty amount of things. So let's start by, well, first the very first thing to consider is here figuring out whether the piece belongs to the color of the current site to move. So let's say it's white to move. So if it's a white piece, then we need to start generating moves for white piece. If it's black, then we need to do this for black. So I hope that's clear. To be honest, I don't really remember where exactly I stopped in regards to the coast and the previous videos. Let me just try to recall that a little bit. So get piece of the board square. Just okay. Yeah, I started simplifying this commentaries because they just, if they go in line by line, I'm going insane with this. So we want to get a piece at the board square. At a board square. Actually at the board square, but I don't have. Okay, forget the article. So get piece of board square. It just, no, we don't need this. Well, that's what it happens literally, but just want to skip this for now. So get piece at board square and store it. Yes, and store it. So and store it. And skip if wrong color goes here. So literally, this is quite simple. Skip if wrong color. It's quite simple thing to consider. So we're getting the so y is now I'm initializing, I'm transferring the value of the A register to the Y register, which is square currently, and then I'm loading the value at board index by the Y, which is square now again, and then I want to store it as the piece. So just adjusting the x index to make sure I'm targeting the correct local variable in a stack, storing it there. And then so I store it anyway, and if it's kind of wrong color, then I skip it. So just like we have in our C code, so the piece is being stored anyway, and then if it's the wrong color, then we just move on. Otherwise we do a whole lot of logic there. So then all we need to do is just bitwise end the current piece. So whatever, so here a piece is already in the A register, so bitwise in with the site to move. So the site to move is now 8, which stands for white. So, and if it does belong, in this case, where is that? Yeah, and if it does belong, no, hold on a sec. Here, if it does belong to the site to move, then we continue here. Otherwise, we just go into the next square. Nothing to talk about. And just to give you a visual idea of how exactly this the pieces that belong to the site to move are being picked up and being distinguished from the rest of pieces, from the opponent's pieces, basically. Here I made this, I've added these 2 lines of code that I will now delete, and they just do load to set a marker, like to mark all white squares with AA, just to make sure that engine does see those pieces properly. Right, so I just assemble this and upload 0200 and run, and go into the hex dump, and here we go. So we have this AA in the places where the white pieces should be. So this is our board here. So this is the p squared table. This is the rest of the variables, and next we'll be inspecting the stack. So I hope this is clear. So now as far as this is clear, hopefully I can get rid of this. And now the next thing, we need to extract the type of our piece. So it's like in the C code, we want to extract the type and the directions. Now this is going to be really interesting. I'm going to spend time trying to explain that. But the type is self-explanatory, so we just bitwise end piece with 7. Just to extract the at least 3 bits. And that would represent the type of the piece. We're going to be using this variable later on in the program. Right. So yeah, extracting the piece type, adjusting the x offset to make sure that we store in the proper stack plus 8. So that would be relatively this place. So I'll show you how these variables are being initialized on the stack. That's incredibly interesting to inspect, to be honest. Well, this is for me personally. And then extract and store directions offset for piece type to use as a starting index to loop over. So I think where do I? Yeah, I probably just stop here. I add this break statement here. We're not going to be looking at this just right in the moment, and this code as well. But for now, let's actually assemble, upload 0200 run, and have a look at our stack. So 0x from 200s, from 100s to 200s hexadecimal, and let's have a look. So just to give you an idea in regards to, again, like this map, this is really helpful. So we have the address where we've called our search function from. This is the depth, and now 60 stands for a square where the first white piece occurs. So this square is the span actually, because it goes like from here, then there, so on, and it finally comes here. So this is the very first white piece to generate moves for this span in particular. Then target square is skipped because we didn't yet initialize that. So we have the store square, destination square is skipped, it still equals to 0. Then the piece, so the piece is white pawn, which has the code of 9. So we have this piece being stored. Now we need to extract the type. So if we bitwise end 9 with 7, we're gonna have exactly 1. You can try to check that out if you don't believe me, because we have in binary we have 1 0 0 1, and to bitwise end with is gonna be 1. Is gonna be 0 1 1 1. So the highest bit gets stripped, and the lowest bit remains, so 9 turns into 1. So this is how we strip our thing. Then what we want to do next, okay, square loop, so break here, right? Okay, and the next thing, directions, yeah. So what the directions is, so here, these directions. So we want to, this type plus 1f allows us to point starting from this cell. So here we have, so these values are kind of references of where to reference this move offsets to get a starting index for a given piece type offsets. So for instance, this 4 is for a pawn for a black, well actually for yeah, here actually I have, so this should be actually white pawns. This should be white pawns and this should be black pawns. So just a little bit of a mistake. So 4 0 1 2 3 4, and then the next, starting from the next offset, we're gonna be having our offsets for white pawns. So we first need to add 1f to type to make a point in here. And then we need to extract this 4, which is an index of where we're supposed to be looking the move offsets for moves for white pawn. So this might be a little bit mind-boggling, but it's not so if you walk through this like hundreds of times like I did. when I've been implementing these engines, I don't know, really lots of time. I mean, really kind of many times in a row, even before this 650 assembly port. Okay, so where did I stop? Yeah, so the direction. So we add in this 1f, initializing y as an index, as an offset index to index the offsets. So after this operations, we have the value for actually after this operation, we're storing this 4 into the A register, yeah, and then we adjust the X to store it to the proper variable, which is called directions. So directions is stack pointer plus 6. We're going to be using this just right in a moment, and there we store whatever we have in the A register, which is 4. Now next then, square loop, or hold on a sec. Oh, no, not here. And yeah, adjusting the axis to store the directions. Now, currently, we are at this break statement. So if I go to 0 to 4D and execute this, now I've just executed this offset loop one more time. So it's now interesting to inspect. This hex done one more time. So, oh, what have I done? Oh no, sorry for this, guys. Just ruin everything. So 0 to 0 0. I quickly bring this to where it should be, like this, and now go into a hex stamp, and here we go. So so we had our pawn, piece is pawn, type is 1, and then skips 1, and okay, hold on a sec, I'm not sure where this 5 is coming from, to be honest. Oh, no, this is probably, yeah, so there was 4. There was 4 because directions was equal to 4 when we first break here. So after we increment the directions, if you have a look at the C code, you'll see that we actually do pre-increment the directions here, this plus plus. So that's how it should be. So here's where the 5 comes from, and then 8F. So 4 is the number to index offsets with. So offsets index with 4. 0, 1, 2, 3, 4 was 0, and the last iteration here was 0. Now when it's equal to 5, when the directions is equal to 5, so to this we add like plus 1, so now it's 5, so it's 0, 1, 2, 3, 4, 5, and now we reference this, and this is already the very first offset for a pawn, like one of the possible directions. So I'm not sure, I don't remember whether this is the single step or double step. Yeah, probably this is the single step, and these guys should be the diagonal captures. I don't really remember, but anyway, so the first iteration we have directions plus directions and this offset. Now if I go for one more, so 0 to 4D and one more time, now it should be the direction should be 0, 6, and the offset for pounds should be 90. So let's have a look at that. All right, and exactly, so this is 0, 6, and this is 90. And as you've already guessed, what's going to be happening next? So next, it's going to be 7 and 91, and next is going to be 8, and the step vector. So this value is called the step vector. So we do need to, if you have a look at the C code, we initialize our step vector by this move offsets index by the newly updated incremented directions. And in the assembly code, the step vector is being initialized square loop, offset loop. So first we add carry plus 6. So here we extract the directions. Pointing this to yeah, and then we increment the directions in the stack memory. So the local variables getting incremented. Then we're getting the value of that. Turning this into y, transferring this into y. Then here we load this. We're getting the step vector. So here we're getting the step vector, and then we're storing the step vector next after the next variable after the directions, which is actually literally the step vector. So here we just store the step vector. And now the condition to escape from this loop is quite simple. So if we have a look at the C code again, so while not captured piece, I'm sorry, no, it's not here. While step vector is equal, well, actually, while step vector is not equal to 0. So as far as the step vector is equal to whatever, but not 0, so it was equal to 8f, 90, 91. But then step vector is equal to 0, which means the following thing. So yeah, so here we're ADC plus 5, so we're having this stack pointer plus 5 is the step vector. So we are re-initializing the step vector, so it's now in the A register. Yeah. And then loading the value there. So you need to initialize the x in X register, loading the value of the step vector for current given depth from a local variable, comparing it with a 0, and in case if it's not 0, then we loop back to the offset loop to loop through the rest of those kind of offsets. So just to show you this, well, I didn't yet test this basically, but it's quite interesting to have a look. So, well, first, well, actually, okay, let's just do like again for D, and now, if I'm not mistaken, it now probably should already go for next piece. So let's have a look. No, it's actually 0 here. Or no, hold on a sec. No, it's still. Yeah, it's 0. So yeah, probably the next iteration. 0, 2, 4D. And now maybe. So I just want to see it goes to the next piece. Oh, it doesn't because, okay, it goes to 8f again because we have up to 8 pawns there. So I really need to make a whole lot of times, and actually only the knights would be having, well, no, actually all the pieces, because we don't yet restrict any moves. But yeah, I just need to fast forward manually kind of too much, because just what happens here. So it first loops through all of the offsets for this pawn, then for this pawn, then for this pawn, and only then it would be this rook and so. So yeah, it just kind of takes a little bit of a time. So I would rather be demonstrating you this visually when I would keep the only piece on a board and all the target squares where it's supposed to be going, the step vectors. I just would have been marking them with some random value to give a visual idea on a hex dump of a board, like where exactly, say, the knight is going to be coming or whatever other piece. And then we'll go for looping over the attack rate squares. So yeah, did I? Yeah, actually we walked through all of the code. So the next major step is to initialize the target square. So just to give an idea, a bit of a teaser for the next part, hopefully. So yeah, so I actually implemented this line, actually these 3 lines since the last video. Yeah, it's quite slow doing this in 6-mode assembly. So now I need to initialize the destination square, and probably I just make a separate video on this, even though it's trivial from the code perspective, but it should be quite interesting from the perspective of visual understanding of how exactly the mode generator works. And then we go for this most hardcore part, which takes ages to complete, but yeah, hopefully one day. Okay guys, this is it from my side. Thanks for watching. Until the next time, and take care.